Hello everyone, welcome to Sampai again. So far we have already imported all the necessary libraries, we have imported our dataset, we have properly understood our data, and we have visualized our data as well, and we have got all the basic information we need from our dataset. Now we are ready to go. So what we are going to do now, we're going to handle the categorical data first by doing the label encoding. So for that, as you can see, we have the geography column and the gender column that are categorical data. Like in the geography column, we have Germany, Spain, and France. That means three countries. That is categorical data. And in the gender column, we have male and female. That is categorical data as well. But if we try to go to the next step without handling the categorical data, I mean without doing the label encoding, then our machine learning model will get confused. They will not understand what's going on properly, because right now our geography and gender columns, they are object type data type, and but we need them to be categorical. Like we have right now Germany, France, and Spain. And what we can do, if we do label encoding, it will transform into the numerical one, like 0 1 2, like this. And for the gender, it would be 0 and 1. And so to do label encoding, what are we going to do? We are taking the geography and gender column in a variable, and then we use a simple for loop and transform these columns into category into numerical one. And then we check the dataset, and as you can see, we have our geography column that is now integer type data type, and gender column that is integer type data type as well. Earlier we had object type of this data. Now we have transformed them into the integer data type. And one thing you need to notice here, that we have still an object type data type, like our surname, that is object type data type. But we are not dealing with them right now. But why? As we can see, our surname is not actually affecting our data in any ways. It is not affecting our overall data type. It means it is not affecting our target column, and this is why we can easily get rid of them by dropping them. And we'll do that. We'll drop all the unnecessary column that we'll not need. So for that, we simply check our column names again, and we are using df.case to check our column names. We can use df.columns function as well. Both will give the same output, not a big deal. And now what we are doing, we are dropping all the unnecessary columns and removing them from our data set. We have our in place true here. That means we are removing these columns from the main data set we have. So we are using df.drop function to drop row number, customer ID, and surname. So we have successfully dropped our unnecessary columns and remove them from dataset. And now what we are going to do, we are going to distribute the plot to distribute our plot. We have 2 rows and 5 columns. As you can see here, this is our distribution plot distribution, and we have 2 rows and 5 columns. And we are choosing 16 by 4 as our figure size. You can choose any size you want. And this sounds fine to me, that's why I'm choosing 16 by 4. And n rows and n columns, indicating the column and the rows here. And we have the columns from the df.column, that is the columns from our dataset. And then we are taking from index 0. And now we are using 2 for loop, that is a nested for loop. And using a nested for loop, we are distributing our plot right here, and we are increasing the index one by one, and then as you can see, this is our distribution plot, and this sounds very nice to me. This seems very nice. So for the next step we are going to do, we are splitting the data into dependent and independent column. That means uh, we'll separate our target column from the main data frame. So in the x-axis, in the x variable, we have all the column except the target columns, and in the y variable we have our target column. So as you can see, we check x dot head, and we have all the columns here except the target variable that is exited, and in the y variable we have our target variable that is exited. And now what we are doing here, we are splitting the dataset into training and test set. Training data to train our model, and test dataset to check our data how good it's performing. And for that we have our x train, x test, y train, y test, and we are using train test split function to split our dataset, and we are selecting test size as 0.2, that is 20% of our overall dataset. You can select 25% or 30%. Most of the time 20 to 30% dataset is good as test data, and we are giving a random state 13. 13 is my favorite number, that's why I'm selecting 13. You can give any random state if you want, and then we print our shape of the x train, x test, y train, and y test. And as you can see, we have 20% of our data as test data and 80% of our data as train data. And we have completed all the necessary steps we need, and now it's time to perform machine learning models on our dataset. And we'll perform logistic regression, that is a classification model though, and we'll try naive based classifier, we'll try decision tree classifier, random forest classifier, etc. And then we'll check which one is performing well on our dataset. We'll evaluate our model using some evaluation metrics. So I'm ending this video here. See you in the next video.